Hi, in this video I would like to talk to you about solving systems of equations graphically and what that means, what's going on behind all of that, to give you a visual representation of a big concept that we'll be pursuing more as we continue. So the basic idea here is that you would be asked to graph two equations on the same grid and then determine whether or not those graphs intersect, and if so, at what points. So the two equations I've been given so far are y equals x plus 2 and y equals negative 4x plus 7. We're going to come over here where I've got some graphing paper set up. I'm going to look at both of those equations. I'll start with the first one. Y is equal to x plus 2. You should hopefully recognize that that is in what we call slope-intercept form, which is probably the most common form, sort of the most overused form by students of y equals mx plus b. That is also called slope-intercept form. And you should already be familiar with this. And the great thing about slope-intercept form is that it helps us to figure out how to draw a graph of that very, very quickly. Because what we have here is, right here is our m, our slope, and right here is our b. Of course, our m in this case is really a 1. There's that sort of hidden 1 because it means 1 times x when I write an x. So my slope is 1 and my y-intercept is 2. We tend to start with our y-intercept. So I'm going to put a point here at 0, 2. And then a slope of 1 means that you are going to move in such a way, you probably learned it as rise over run, something like that. But you're going to move in such a way that you go over 1 unit and up 1 unit. So you're going up 1 unit for every 1 unit that you go over in the x direction. So that puts another point here. I can do a very similar thing here. I think that's not quite showing thick enough, where I go over 1 and I go up 1. So over 1 and up 1, and that puts another point. And we pretty well get the point, here of how to deal with that then, and how to then graph a line. So we're going to try to graph a line there. Goes through those points. I don't have the magic of a straight edge, so I'm having to just use the straight edge ability here. Extend that. You do want to extend that pretty well. And as you're extending it, make sure that it is seeming to do what it should be, in that it should be giving going across all those little crosshairs right there. So do a really, really good job of graphing this. Uh-oh, that one looks like it's a little bit off. Wasn't as careful as I could have been with that. That's looking a little better there on that end now. So make sure that you've drawn a really good graph, because we're going to be getting our answer from this based off of our graphs. So there is my first equation. I've graphed that first one of y is equal to x plus 2. None of this should be new to you. You've seen it before. Just easy review here. And now we're going to take the second equation there and graph that one. We have y is equal to negative 4x plus 7. Again, right here we have a slope. The coefficient on x is the slope. I can think of that as negative 4 over 1, negative 4 divided by 1. So that tells me that the y is going to go down by 4 every time the x goes over by 1. And then of course right here we have our y-intercept. In this form, makes it easy to graph. I'll start with the y-intercept. on the y-axis. I'm going to hit at 7. And then I need to do a slope of -4. Slope of -4 means that I'm going to go down 4 and over 1. Well, that's kind of cool. That puts a point right there where I already had a point from the other line. Just checking myself one more. From there, I would go down 4 and over 1 to get another point. And so I'm going to create a line now, going through all of those. Maybe kind of keep it pink. I'll start by drawing a line from there to there, and then I'll extend it. For myself, I don't get to place a straight edge down there like you guys do. You really want to be doing that, making good use of your straight edge. That really should hit up there just a little bit more if I'm being really careful about the down 4 and over 1 thing. So roughly like that. All right. And because I don't have a straight edge here to work with, mine is not coming out quite as perfectly as I would like, but hopefully you can see pretty well there that these two lines do intersect at the point. Well, if I read that, remember you put the x coordinate first and then the y coordinate, so they intersect at the point 1, 3. So the point of intersection, I like to use PT for an abbreviation for point, but there's so many words that start with INTR in math, I'm going to actually write out the whole word, point of intersection. And my point of intersection is 1, 3. That is also called the solution of the system of equations. The solution of the system of equations. And we'll talk a little more in just a bit about what that means and where we get that wording from. But this is the process for finding a solution to a system of equations graphically. Graph both equations and find the point of intersection if they have one. We're going to go through some more examples here. I'll have to go a bit quicker. The only thing that's going to make this a bit different is some of the algebra that you may have to do before you're able to graph the equations. So if I start here with 2x plus y is equal to 3, I realize very quickly, of course, that that is not in slope-intercept form. It does not look like y equals mx plus b. What I need to do is I need to solve for y here. Fortunately, it already has just one y on that side and it's positive, so the easy thing is to simply subtract 2x from both sides of the equation. This is not the notation that I prefer to use, but I think it may be something that you've seen before, so I will go with it. So here, the 2x and the minus 2x cancel and give me 0, but of course 0 plus y is just y. On this side, the thing you've got to be really careful and understanding of is that 2x, the negative 2x and the 3, are not like terms. They do not combine at all. So you simply have the two terms, negative 2x plus 3. That algebra is something you just need to make sure you're solid on, and it needs to be something you can do virtually in your sleep, that you understand combining like terms, what are like terms, what are not like terms, and how they go together. Once I'm in this, now I see that there's my slope and there's my y-intercept, so I'm able to go and graph that line, starting with a y-intercept of 3. A slope of negative 2 means that I need to go down 2 and over 1. So I get a new point here, right there. I can go and do that again of down 2 and over 1. Gives me another point right here. Or Actually, I messed up my colors there. That's not what I wanted. All right, there we go. Get another point right there. But even better, I want to go and graph the line created by those points. Use something like that. So here we go. Boom. But then I need to extend it. So much easier for you guys because you're going to have those straight edges to help you with all of this. Makes it a lot easier than the way I'm having to go about it here. It's the best I can do. All right, so now we're going to take the second one there. We've got y minus x equals 6. On this one, the thing I'm going to do, I've got the y pretty much the way I want it. I just need to get rid of the x on that side. So I'm going to add x to both sides of this equation. And on this side, the minus x and the plus x add to be 0, and 0 plus y is just y. Over here, the x and the 6 are not like terms, so I just have the two terms, x plus 6. So now I go and graph that, y equals x plus 6. Here is the y-intercept at 6, and then a slope of 1x means go over 1 and up 1, over 1 and up 1. Basically what we've seen already in the previous example. Oh, I keep messing up my my colors there. Thank you for your patience so that I don't have to go and redo this video constantly. All right, and then I'm coming in, going to graph an equation with that. Roughly like that. Clean up my line a little bit, make sure it's working the way it's supposed to. Has that slope it's supposed to. And it's getting off a little bit here, which is frustrating. Alright, that's getting better there. And what we hopefully see, what we're trying to go for there, is that we have that awesome point of intersection that is right here and appears to be at -1, 5. So the only difference in this example was that there was some of this algebra work that needed to get done before we could actually graph the equations. So this is going to be an exercise or a review in some of your algebra skills as well for solving equations.